Mars. Today it's a cold, arid desert. But imagine a different Mars. A planet with flowing rivers, vast lakes, and maybe even life. This wasn't a science fiction dream, it was Mars billions of years ago. Evidence is etched across the Martian surface: dry riverbeds, ancient lake basins, and minerals that form only in the presence of liquid water. This tells a story of a planet that was once much warmer and wetter than the desolate world we see today. We know that Mars had a substantial atmosphere in the past. This atmosphere was likely thicker than it is now, composed mostly of carbon dioxide, much like Earth's early atmosphere. This thick atmosphere acted like a warm blanket, trapping heat from the sun and allowing liquid water to exist on the surface. It's tantalizing to imagine what this ancient Martian world might have looked like. Could life have arisen in those Martian waters? The question remains one of the biggest mysteries in our solar system. So what happened to Mars? Where did its atmosphere, its water, its potential for life, all go? The answer is a slow, drawn-out process of atmospheric loss. Over billions of years, the Martian atmosphere was stripped away, leaving behind the thin, wispy shroud we see today. This atmospheric loss was driven by a combination of factors, each playing a significant role in transforming Mars from a potentially habitable world to the barren planet we know today. One by one, the components that made Mars potentially habitable disappeared. With the atmosphere thinning, the pressure at the surface decreased, causing liquid water to evaporate and eventually vanish into space. The planet's once temperate climate became frigid, locking the remaining water as ice beneath the surface and in the polar ice caps. The once dynamic planet was frozen in time, a stark reminder of the fragility of planetary atmospheres. A planet's magnetic field acts like a protective shield, deflecting the constant bombardment of charged particles streaming from the sun, known as the solar wind. Earth has a strong magnetic field generated by its molten iron core. This field deflects the solar wind, protecting our atmosphere from being stripped away. Mars, however, wasn't so lucky. Early in its history, Mars likely had a magnetic field similar in strength to Earth's. However, over time, Mars's core cooled and solidified, causing its magnetic field to weaken and eventually disappear. Without this protective shield, the solar wind was free to interact directly with the Martian atmosphere. This bombardment of charged particles stripped away the Martian atmosphere, molecule by molecule, over billions of years. The loss of its magnetic field left Mars vulnerable, exposing its atmosphere to the unrelenting onslaught of the solar wind. Section 4. Gravity's grip. Gravity plays a crucial role in a planet's ability to hold onto its atmosphere. Planets with stronger gravitational pull can hold onto more atmospheric gases, while planets with weaker gravity struggle to retain their atmospheres. Mars, unfortunately, falls into the latter category. With only about 38% of Earth's surface gravity, Mars has a significantly weaker gravitational pull. This weak gravity has made it difficult for Mars to hold on to its atmosphere. Lighter molecules, such as hydrogen and helium, escape more easily from Mars's gravitational grasp, further thinning the already tenuous atmosphere. The combination of low gravity and solar wind stripping has left Mars with an atmosphere that is about 100 times thinner than Earth's. This thin atmosphere offers little protection from the harsh conditions of space, making the surface inhospitable to life as we know it. Section 5. A second chance for Mars. Could Mars be terraformed, transformed into a more Earth-like world? It's a question that has captured the imaginations of scientists and science fiction writers alike. Some have proposed ambitious plans to thicken Mars's atmosphere and warm the planet, potentially making it habitable for humans. These ideas involve releasing greenhouse gases trapped in the Martian soil, or diverting comets to impact the planet, releasing water and other volatiles. While terraforming Mars is theoretically possible, it remains a daunting technological challenge. It would require a sustained, coordinated effort over centuries or even millennia. The ethical and environmental implications of such a massive engineering project would also need careful consideration. However, the dream of one day walking on a green and vibrant Mars continues to inspire us to push the boundaries of science and exploration. Perhaps one day we might just be able to give Mars a second chance.